Hydrocarbon alkane, mechanism of free radical substitution. Halogenation of alkane. Alkane reacts with halogens such as chlorine or bromine to produce haloalkene in presence of light. This is general equation. As for example, methane CH4 reacts with bromine Br2 in presence of inert solvent dichloromethane CH2Cl2 and sunlight or ultraviolet UV. The products are bromomethane and hydrogen bromide. Alkane only undergoes bromination in presence of sunlight. Observation: reddish brown color of bromine decolorized. Halogenation of ethane. Bromination of ethane produces bromoethane and hydrogen bromide. This is the chemical equation. One of the hydrogen in ethane is replaced by one bromine. The type of reaction is free radical substitution. There are three steps for the mechanism of free radical substitution. Steps of mechanism. Step 1, chain initiation step. Step 2, chain propagation step. Step 3, chain termination step. In the first step, light supplies the energy for homolytic cleavage of halogen molecule. In the second step, reaction of halogen radical and carbon free radical. In the third step, combination of radicals to form molecule. Chain initiation step. The reaction starts with homolytic cleavage of bromine molecule. First, we write the structure of bromine, bromine single bond bromine. Under presence of sunlight or UV, the bond between bromine atoms breaks. A single bond represents 2 electrons. Since the type of bond cleavage is homolytic cleavage, so 2 electrons divide by 2 bromine atoms. Each of the bromine atom will get 1 electron or 1 unpaired electron. Thus, the first electron transferred to the bromine on the left, the second electron transferred to the bromine on the right. The products form a 2-bromine free radical. Free radical is species with unpaired electron. Chain propagation step. Since bromine is very reactive species, it will attack propane. One of the hydrogen in propane will be attacked by the free radical of bromine. We need to show the single bond between carbon and one of the hydrogen atom in ethane. There are 2 electrons here. Hydrogen atom gets 1 electron and combine with radical of bromine, and the second electron transferred to carbon. Carbon accept 1 unpaired electron and becoming free radicals. Meanwhile, hydrogen combine with bromine to form hydrogen bromide. Next, C dot reacts with bromine molecule. One of the bromine atom gets 1 unpaired electron and combine with unpaired electron from carbon. And then the second electron transferred to the bromine on the right. Formation of bond between carbon and bromine atom accept 1 unpaired electron becoming bromine free radical. Chain termination step. In this step, we need to terminate all of the free radicals produced in the first and second step. Thus, bromine free radical combine with the next bromine free radical to form bromine molecule Br2. Next, carbon free radical combine with the next carbon free radical to form molecule of alkene. Finally, carbon free radical combine with bromine free radical to form molecule of haloalkene. That's all for mechanism of free radical substitution. End of slide. Thank you.